Hernández. I'm a scientist at droplets, and today I'm going to talk about monkeypox, current and upcoming diagnostic test, and biosafety guidelines. So, in this talk, we will get an overview of the monkeypox virus and its characteristics from the current outbreak. We will review the latest guidelines and recommendations for testing, and also we will discuss how an informatic tool such as LIMS can help streamline and automate operations in clinical diagnostic laboratories. Well, let's start. First, we will see what the monkeypox virus is. Well, monkeypox is an emerging zoonotic disease. Zoonosis is a disease that is transmitted from animals to humans. This infection is caused by the monkeypox virus. And this monkeypox virus is classified as an orthopoxvirus and a DNA virus as well. So this virus is transmitted to humans as a result of a close contact with infected animals, such like squirrels, some rats, different species of course, monkeys, and other infected humans. However, the human-to-human transmission is limited, and the longest chain of transmission is reported to be as far as 6 generations. So it's not as transmissible like the virus of the coronavirus, for example. It can be transmitted through contact with body fluids, skin lesions, or internal mucosal surfaces, such as the mouth or the throat. Also by respiratory droplets and contaminated objects or fomites. So the monkeypox has an incubation period of 7 to 14 days and causes symptoms similar to those of the smallpox, but less severe. The symptoms can be fever, headache, fatigue, myalgia, generalized body aches, swollen lymph nodes, and the characteristical skin lesions. So, on July 23rd of 2022, the World Health Organization declared the current monkeypox outbreak a public health emergency of international concern because there are cases in more than 75 countries and the cases continue rising every day. So for this, it can be difficult to distinguish monkeypox based on clinical symptoms alone, especially in cases with an atypical appearance, because there are a number of conditions that can cause these skin rashes. And there are non-specific clinical presentations that have been observed in this disease, lesions and inflammation of the pharyngeal mucosa, for example. So these symptoms can be seen in many other viral and non-viral infections. So that's why the accurate laboratory diagnosis of the disease is of particular importance. Here the laboratory is the MVP and it's the one who will say if it's monkeypox or it's its other infection. So it's a lot of responsibility. So the undercurrent guidelines, testing should be offered to anyone who falls within the definition of a suspect case of monkeypox infection. Samples from anyone suspected of having monkeypox should be tested in properly equipped laboratories by personnel trained in the relevant safety procedures. The monkeypox, as the coronavirus was, is a disease that presents challenges for public health and health workers in terms of surveillance and laboratory capacities. So, speaking about laboratory diagnosis, the confirmation of monkeypox virus is based on the nucleic acid amplification test using conventional or real-time polymerase chain reaction, or the extremely famous in a couple of years, the PCR. In this for the detection of the viral DNA. So this PCR can be used alone or with the sequencing for foolproof confirmation. And in this particular disease, the antigen and the antibody detection methods, they're not recommended because they do not distinguish between the different kinds of our orthopoxvirus. So the guidelines said that they are not recommended right now. So the National Institutes of Health, the CDC, as well as different health organizations, such as the Health Security Agency of the United Kingdom and many others across the globe, recommend that the health departments of each location ensure the timely identification of suspected cases. Also, the timely collection of samples and all the process of them, from storage, transportation, testing, and reporting in public health laboratories, and also the implementation of security protocols. So these organizations give us some biosafety measures that all laboratories must follow. For example, the test must be carried out in properly equipped laboratories. Biological safety level as minimum 2 by the personnel training in the relevant technical and safety procedures. Also, the laboratories have to take measures to minimize the risk of laboratory transmission and cross-contamination by conducting a risk assessment when testing routine clinical specimens from patients with confirmed or suspected monkeypox. Also, they gave us some biosafety considerations, and some of them is that laboratories must establish appropriate standard operating procedures of SOPs, and the laboratory staff must be trained in the proper use of personal protective equipment that, of course, the laboratory must provide. Laboratories also have to minimize the risk of transmission, and the staff that will be testing the samples should be competent staff only. The guidelines are very repetitive in this. The staff must be always be training and up to date with the latest SOPs. They have to rigorously enforce the standard precautions. They have to use effective disinfectants. When they are manipulating, or they will be manipulating biological specimen, it has to be in biosafety level 2 as minimum. And if laboratories need to use a centrifuge for any procedure, safety cups or sealed routers should be used to avoid any spill. And for the sample collection, they gave us some recommendations. Laboratories or the staff in the laboratory must wipe lesion with sterile synthetic swabs, and they have to collect 2 lesions of the same type in a single tube from different places of the body and of different appearance. The laboratory staff can use dry swabs or swabs in viral transport media, the VTM, but not the one that has media for bacteria, because we will have a really bad cocktail of bacteria there. So only the viral transport media. And they have to remove the gloves and wash the hands to avoid cross-contamination. For the sample storage, the laboratories must identify all the samples using 2 identifiers and specimen information. Can be the patient name, can be the patient date of birth, gender, or a unique ID, such as a barcode, for example. And also they have to use sterile leak-proof containers, and the monkeypox specimens should be refrigerated at a temperature of 2 to 8 degrees Celsius as soon as it has been collected. And if the test is conducted more than 7 days later, the specimen should be frozen at a temperature of minus 20 degrees Celsius or lower. Now with the next chain of the process is the sample transportation. So according to the current guidelines, the sample should be stored, refrigerated or frozen within 1 hour of collection and transported to the laboratory as soon as possible. The facilities must ensure that all the personnel are trained in specimen handling and spill decontamination procedures. And all the specimens that are being transported should have appropriate triple packaging, proper labeling. They have to have also the patient history form and coolers and cold packs or dry bags. Now the testing. Well, several diagnostic testing were performed from previous outbreaks of monkeypox. For example, the LAMP, loop-mediated isothermal amplification. These isothermal amplification methods do not depend on thermal cyclers and reduce diagnostic costs tremendously. However, these methods have certain limitations in terms of selectivity and ease of operation. But maybe in some laboratories that they don't have these expensive thermocyclers across the globe, well, probably they are still using this method. Another one is the microarray. This method allows to discriminating between different species of human orthopoxvirus and herpes virus. This can be used for the identification of gene subsets responsible for differences in pathogenesis and virulence. And this may help again to gain insights into microbial evolution and genome heterogeneity. So for me, this is more for research, not such as routine test for monkeypox virus. Another one is the FRED RT-PCR. This is a fluorescence resonance energy transfer, and this real-time PCR assay can detect and differentiate human pathogenic orthopox viruses. Other one is the NEST multiplex PCR. This method can be used for viral identification and control of orthopox virus, and the other one that is the parapox virus. So these are some tests that are being done across the globe for this type of viruses. But there are molecular methods that are currently used for confirmation of monkeypox virus and are based on the nucleic acid amplification test and using a real-time PCR for the detection of the viral DNA. And the DNA can be extracted from samples using any validated standard extraction protocol or kit. And of course, they have to use external, internal, positive, and negative controls to validate these results. So these are extremely important to give the validation of the results in any laboratory. So when we have a positive case with a PCR test for orthopox virus, it is needed confirmation of monkeypox virus by another PCR test or by sequencing. And for suspected cases in an endemic or a non-endemic area, a positive case with a PCR for monkeypox virus provides a confirmation of monkeypox virus. Okay, and also the genetic sequence data, the GSD, provide us information of the origin and epidemic in the characteristic of the cases. So this algorithm can help you to see if you need an additional test, PCR test, or it's enough with that. So speaking about reporting, well, due to the public health risk associated with a single case of monkeypox, the established protocol is that the clinician should immediately report suspected cases to state and federal health authorities. So any confirmed case should be reported to their National Institutes of Health. Well, we know that the test data and results are crucial in a pandemic. We have learned this from this couple of years. The timely numbers can help predict increases in demand for tests and plan for potential problems in supply chains of reagents and other testing materials. So all the laboratories that perform diagnostic tests for monkeypox must report these results to the state, tribal, local, or territorial health departments. And all the results, positive and negative, must be reported unless otherwise specified by the health department. And this is very important because in a rise of cases, well, all the laboratories must be prepared with their supplies and they have to check their inventory. So it is important to check the numbers in every country and every city. So the positive results should be reported within 24 hours of testing, or if it's possible, immediately by phone to the appropriate STLT health department. And now let's speak something about the waste management. And this is kind of similar to all the medical waste management protocols. The sharps should be disposed in an appropriate container for autoclaving as an infectious waste. And all the monkeypox virus cultures, stock, residual samples, and waste should be decontaminated before disposal by any approved method. And well, the most common and the most easier is the autoclaving. And all the contaminated materials must be placed in a durable leak-proof container and closed for transfer from the laboratory. So we'll see all the recommendations, the guidelines, and we'll see that it's a lot, considering the volume of samples that the labs are receiving and considering the volume of samples that they will receive in the next months, next year. So what can we do to minimize all this challenge? Well, an informatic tool such as LIMS can help you with that. How? Well, LIMS can help you to manage patient data, can help you to manage different types of test methods, can help you also to generate custom reports, to manage calibration and maintenance of your instruments. The LIMS also can help you to report monkeypox test results following the FDA and CDC reporting guidelines and to deliver test results securely and digitally. Let's see how. So, LIMS can help you to securely manage patient data. How? Well, it anonymizes sensitive participant data and assigns role-based protect health information access rights to the staff. So the masked data can be viewed only by authorized personnel. Each time an authorized personnel views or makes any changes to these PHI, the activity is recorded in the audit trail. So this is really useful for audits because sometimes the external auditors can request a PHI audit report at any time. So you have it here automatically. You don't have to worry about anything. The LIMS do this for you. Also, you can manage the different tests in the laboratory. You can select the type of test that your laboratory performs. For example, if you're doing RT-PCR, if you are doing sequencing or LAMP, you can do it here in your LIMS. Also, LIMS help generated custom reports, and well, you can have in there as you want all the provider information, all the patient data, the sample information, the test results. You can flag the abnormal results. You can put your logo or your provider signature, and all of this with a click with the LIMS. Also, LIMS can help you to schedule calibration and maintenance of the instruments. We know that in a laboratory of diagnostics, you have a lot of instruments, and sometimes it's really difficult to be up to date with all of them. So you can schedule instrument calibration and manage maintenance data. And there's a built-in alert system that will inform the lab manager or the personnel responsible of any instrument to a preset number of days ahead of any needed maintenance or calibration. So your lab manager can call the technician and schedule the appointment to get the calibration up to date anytime, and it's audit proof. Also, you can securely deliver test reports to the patients via a secure patient portal. So this is really cool because the patient has their portal and they can access them to their results when it's ready. So in the commodity of his computer, the patient can access and see what is their results. And similarly, you can securely deliver test reports to physicians via secure physician or provider portal. So your providers have their own portal and they can see all their results of all their patients. So they have it on a click. Also, LIMS can help you to reorder the test, or you can use it for the next test in the infection detection hierarchy. With this function, it's the reflex text order. So, in conclusion, LIMS increases efficiency, eliminated human errors, improves the data quality, and therefore boosts the validity and reliability of monkeypox test results of any result in a laboratory of diagnosis. So thank you very much for your attention.